This video is about using integer chips to do integer addition. One term we need to know before we can do integer addition using the integer chips, we need to know what a zero pair is. So a zero pair is a pair of integer chips with one chip representing a positive 1 and the other chip representing a negative 1. So for example, we're going to draw our chips as circles, and this would be a positive chip and this would be a negative chip. So this one represents a positive 1, this one represents a negative 1. So we'll put those in brackets there. Now when I put those two together, they're called a zero pair because those two chips, or that pair, equals 0. Equals 0. Okay, so you have to know what a zero pair is going forward here to do addition, and then later on when we do subtraction. So let's look at the rules now. So here are the rules for addition using integer chips. So the very first one, draw the integer chips to model the first integer in the statement. So let's make a statement here. Let's say that it's 3 plus 4. Now I know you already know the answer to that just by looking at it, but I'm going to show you a visual way using integer chips to show why 3 plus 4 equals 7. So the first step says to draw the integer chips to model the first integer in the statement. So on my paper I would draw 3 positive chips. That's the first integer. Okay, so that's this first integer here. Next, step 2 says below the first row of chips, draw integer chips to model the second integer in the statement. So now I have my 3 positive chips and I'm adding the next integer to it. So I'm adding to the visual the next integer, which is 4. So my next line is going to be 4 positive chips. Okay, so now I have drawn chips representing both integers. Third step says strike a line through any zero pairs which have been created. Now remember, a zero pair is a positive chip and a negative chip. So we look at our integers we've drawn out here, our chips. Do we have any zero pairs? We do not. So in this instance, we don't need to strike a line through any. So we move to step 4. After removing the zero pairs, remaining integer chips represent the final answer. So now all I got to do is count all of these up. So 1, 2, 3, 4, 5, 6, 7. So 3 plus 4 equals 7. All right, now let's try one a little bit more interesting than that. So let's say that we have, how about a negative 3 plus 4? All right, same numerals, got change in signs here. So again, first step, I'm going to draw the first integer using chips. So I need 3 negative chips. Okay, that's our first integer. Now I need to add to it my second integer, 4 positive chips. Second line, I put the next integer, 1, 2, 3, 4. All right, now I've drawn both integers. Third one, strike a line through any zero pairs which have been created. So remember, a zero pair is a positive chip and a negative chip. So I look here and I have a zero pair here. So I'm going to strike a line through it. So remember that right there represents 0. So it's just gone. Another one, gone. Another one, gone. Now I have no more zero pairs to create. Step 4 says after removing the zero pairs, the remaining integer chips represent the final answer. So my final answer is positive 1. So negative 3 plus 4 equals positive 1. Let's do another example. Let's move down here a little bit. Examples of integer chip addition. How about 6 plus negative 9. Okay, 6 plus negative 9. First step, draw the first integer. 2, 3, 4, 5, 6 chips. Okay, second step is to draw the second integer. Add it to the group of chips I already have. I need 9 negatives. 2, 3, 4, 5, 6, 7, 8, 9. Next step is to cross out any zero pairs that are created. 1 zero pair, there's another one, there's another one, there's another one, there's another one, there's another one. All the zero pairs I have. Okay, I can't cross these guys out because that doesn't create a zero pair. So now that I have all the zero pairs canceled out, whatever chips are remaining, I count those up and that is my answer. So I have 1, 2, 3. So this equals negative 3. Now, why is it a negative 3, not a positive? It's a negative 3 because each of these here are negative chips. So then the answer is negative. Let's do another one. 14. Ooh, now we're going to show why we don't like doing this with big numbers. Subtract plus negative 4. Okay, so now I'm going to do 14 chips. So as I do this one, it's a demonstration of why integer chips are great for smaller numbers, but terrible for larger numbers. Okay, there's 14. So you can imagine if you had a question like 51 plus a negative 32. Okay, that would be, we wouldn't want to use this method for that. So there's my 14. Now I'm going to add my negative 4. Negative 4 chips on the bottom. Next step again, cross off the 0 pairs. All the 0 pairs have been made. And now I'm going to count up the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it equals 10. And these chips are all positive, so it's 10 positive. Okay, if you still don't understand those, back the video up and watch it through again. Now I'm going to give another example of one that you'll see. So sometimes you'll see something that says like this: 3 plus negative 5 plus 4. So this one has 3 integers in it, but we can use chips in the same exact way. So I start on the left, always on the left, go in this direction. Draw my chips. 1, 2, 3. Now I'm going to draw my next integer, which is 5 negatives. 1, 2, 3, 4, 5. Next, I'm going to draw my next integer, which is a positive 4. Now, because we're adding these, you can do this in 2 different ways. Some would put them down here on the bottom, or some would just add them onto the positives over here. 1, 2, 3, 4. So now I have my 4 chips and my 3 chips that are positive, and I have my 5 chips. So then I would go to the next step as usual, cross off the 0 pairs, and the remaining chips are my answer, 2 positive. Now if we back that up a hair, okay, we're going to back that up a little bit. Sometimes people will put this on the bottom, so they will put their 4 positive chips down here, which again is right, but you have to be careful here. Occasionally what we see here, the mistake occurs when people then will cross this whole list off. Now our issue here is a 0 pair is a pair, so only 2 chips. So a negative and a positive. Again, negative 1 plus 1 equals 0, so it's a 0 pair. Negative 1, in this instance over here, plus 1 equals 1, so that doesn't work for us. Okay, so we have to be careful. If we're going to put them underneath, we have to be careful that we're only crossing off negative pairs. Sorry, 0 pairs. Okay, so now then I could just cross this one off, and I could get rid of that one and that one. So then I would still have my 2 left over, as I know the answer is. Let's try one more of those, and then we're going to allow you to go do some practice on your own. So let's say it's negative 7 plus 6 plus negative 2. Negative 7 chips to start. 2, 3, 4, 5, 6, 7. I will now add my 6 on the bottom. 3, 4, 5, 6. Oh wow, what did I do here? 1, 2, 3, 4, 5, 6. Oh wow, too many. So you got to be also be careful there. Now I need to add my negative 2. I'm going to add those on the end of the rest of my negatives. Now I take out my 0 pairs. 1, 2, 3, 4, 5, 6. What does that leave me with? The answer is negative 3. So that's integer addition.